Hello, and thank you for studying CCNA with Vombar. So far, we've been talking about different routing protocols and how we can use those routing protocols to connect different networks together and so they can communicate between each other. However, being able to access every computer on every advertised network is not always the desired effect. There should be a strict control of who gets access to a given network, despite the fact that routers know how to reach that network. Well, one way to implement such control is by the use of access control lists, or ACLs, and that's what we're going to do now. First, we'll see what exactly we can use the access list for, and then we'll see how actually the access lists work. After that, we'll discuss what are the different types of access lists and how we can configure those access lists. Well, it is said that there are two main uses of access lists. The first one is for regular traffic filtering, meaning that access lists can block traffic that is passing through the route. And I'm emphasizing through because if a traffic is destined to the route itself, the access list won't be able to block it. The only traffic destined to the router that an access list can filter is VTY traffic, or in other words, any remote access traffic like Telnet, SSH, RLogin, and so forth and so forth and so forth. So, for example, if we have an access list applied here and the access list does filtering, the access list says that it blocks only incoming FTP traffic. So if you have HTTP traffic coming in, the access list checks that traffic, determines that it's HTTP, so it allows the actual traffic. But if we're trying to send in FTP, when the access list checks that traffic, it determines that this is FTP traffic, and the access list is set to block that traffic, so it is not permitted to go into network A, where the host A resides. The second use of access list is classification. And basically here, what does it mean is that the access list does not do filtering, meaning that it does not block the actual traffic. What it actually does is marks the traffic as special, so some other protocol or feature can do something with it. As a matter of fact, traffic classification is a more common use today for access lists. But now let's see here an example. For example, we have an access list that is defined in router A that says to mark only traffic that is coming from network A and is going to network C. And then we have a VPN tunnel that connects the two networks together, and it says that to allow only traffic that is coming from network A and is going to network C. That means any traffic that is marked as special by the access list. So if we have a network B trying to send packets there, because the traffic is not marked as special by the access list, the traffic will not be allowed to go through the tunnel. But that doesn't mean that the actual traffic is blocked. What that means is that network B can freely access the Cisco server if it feels like it. It doesn't block the actual traffic that is coming from network B. It just doesn't mark it as special, so it is not allowed to travel through the VPN tunnel. Well, if a network A though is trying to go to network C, the access list now realizes that this traffic is coming from network A and is going to network C, so it will mark it as special, so this traffic is actually allowed to go through the VPN tunnel. Well, also, that doesn't mean that all kinds of traffic that is coming from network A will be going through the tunnel. If network A is trying to access the Cisco server, it will be accessed with no problem whatsoever because the access list only marks traffic that is going from network A to network B specifically. Access lists can also be used by NAT to classify or specify who's allowed to be translated, or by routing protocols to specify what networks are allowed to be redistributed to another protocol, and so forth and so forth. As a matter of fact, you use, again, as I said, access lists for classification more than you actually do it for filtering nowadays, because you have a complicated and complex firewalls and IDSs and IPS. Access lists works on the router's interfaces, where the traffic is actually received and sent out from. They don't work on the router specifically. Also, access lists are said to have directions to which they work, meaning they can be inbound or outbound access lists. Inbound access lists are set to filter traffic that is coming into the interface from some other place. They cannot filter traffic that is going out of that interface because simply they don't check that. That is the job for outbound access lists. Outbound access lists can actually filter the traffic that is going out of the interface, but they cannot filter traffic that is coming into the interface because we just said that that's the job for inbound access lists. Also, there's a slight difference in the whole use of inbound and outbound access, even though they actually do the same job, filter traffic or classify traffic. It is said that On an inbound access list, the traffic is checked before it is going to the router, meaning it's checked against the routing table to determine whether there is a path to this destination or not. Whereas an outbound access list is used when the traffic already has passed through the router, meaning it's checked the routing table, checks whether there is a path to this network, determine the outbound interface, and only after all these processes, the traffic is checked against the access list. So you might argue that it is a little bit faster, or you save the router some processing time by implementing only inbound access lists, because what is the point of checking traffic against the routing table to try to define outbound interface if the traffic is going to be blocked by an access list anyways? But there is an argument to both sides, so I'm not going to go into the details of that thing. There are two types of access lists depending on what criteria do they use to check and match different types of traffic. The two types of access lists are standard and extended access lists. Standard access lists are set to check against only source IP addresses, meaning they check only where the traffic is coming from, and based on that they do their decisions. They don't care where the traffic is going to or what type of traffic is the packet part of. Whereas an extended access list, they check where the traffic is going to and is coming from, what types of protocol is carrying, and ports within those protocols. So basically that means that extended access lists can specify that they want to block only telnet or FTP traffic that is coming from a specific host and is going to a specific host, whereas standard access lists cannot do that. As much as they can do is specify where the traffic is coming from, but not where the traffic is going to, or whether it is a telnet or FTP or any other type of traffic for that matter. So in today's world, most of the times you will actually have to use an extended access list if you want to do more granular and more expert decisions on filtering traffic. There are two ways to identify whether an access list is standard or extended. We can identify them by number, whereas for standard access lists we will have to use number between 1 and 99, and for extended access lists we would have to use the number between 100 and 199. But also we can identify access lists by names, meaning we can call an access list junk traffic or bad traffic or whatever traffic we want. However, also we would have to use a keyword to specify whether the named access list is standard or extended. So if we want to make a standard named access list, we would have to type the keyword standard and some name. And if we wanted to for extended access list, we would have to type extended plus some name. Now that we know what is the criteria that access lists use, let's see how exactly or what exactly do they do to filter the traffic. It is said that access list is constructed of access list statement. Each statement has a matching criteria, and if the traffic that is being checked matches that criteria, the statement will specify whether the traffic should be denied or whether traffic should be permitted. If there is no match, then the packet is checked against the second access list statement, and so forth and so forth and so forth in a top-down approach. When an access list finds a matching statement, the access list skips the checking of the rest of the statements of the access list and does whatever the access list statement tells it to be done. In the end of every access list statement, there is an implicit deny everything. So if there is no match on any of the user-defined access list statement, the access list will block the traffic by default. Also, this raises a note that you should have at least one permit statement, otherwise the access will block absolutely every kind of traffic. Now that we have explained how an access list works, let's consider the following example. We have a standard numbered access list, and there are three statements in it. One deny, one permit, and then the implicit deny everything in the bottom. If host A is to send a packet or is to open a web page at the cisco.com, the packet will look something like that. It will have the source address, the destination address, source port, destination port, and the protocol. So when the packet is received by the router determines that this packet has to be checked against an outbound access list 15. Since this is a standard access list, the access will care only about the source address. So we're starting in a top-down approach with the first statement, and we'll see, does the source address of 200.200.200 belong in the 200.200.200 network? Yes, it belongs. There is a match. So that means that the access list should actually do what this access statement tells it to do. Well, the access statement specifies that the traffic from source 200.200.200.0 should be denied, so the traffic is dropped. If host B, however, is to send a packet to the cisco.com, when the packet arrives at the router again will do exactly the same thing. It determines that it needs to be checked against the access list 15 and starts in a top-down approach. Is the source 192.168.2.1 within the 200 network? No, it's not. So there is no match. So I'm going to the next access list statement. Is the source 192.168.2.1 within everywhere or everything? Yes, it is. So there is a match. The access statement says that the traffic should be permitted, so the traffic is allowed to go on its way. In our case, the access list will never go to the implicit deny everything, because on the top of that statement we have permit everything. So there will always be a match there, so the router will not look at the last thing or the implicit deny everywhere. Let's try another example, but this time we'll use an extended access list. As you remember, an extended access list checks the source, destination, protocols, and port numbers to determine whether there is a specific match against the access statement. The extended access also uses top-down approach and also have an implicit deny everything for all kinds of traffic in the end. So, if we have a host A accessing the Yahoo server and it tries to open a web page, the packet will look like this. It has a source address of 200.200.200.200, destination the Yahoo server, destination port 80, and protocol TCP, and the source address we don't care. So when the traffic arrives at the router determines the outbound interface and it determines that there is an extended access list 105 applying in outbound direction. So that means that the traffic has to be checked against that access list. And let's start checking. Well, is the source address of the packet within the 200.200.200 network? Yes, it is. Okay, is the destination 64.84.29.204? Yes, the destination is that. Well, is the traffic HTTP? Well, the destination port and protocol can tell us that, and actually they're telling us yes, it is, because port 80 and protocol TCP specify exactly HTTP traffic. Then that means there is a match. And this access list statement says that the traffic should be denied, so the traffic is actually dropped. Now, if the host A is trying to access a mail at yahoo.com, it's going to go and use port 25, which is the SMTP. So when the traffic goes into here, the router will have to check the packet against the access list statements in a top-down approach. So we're starting again. Is the source within this network? Yes, it is. Is the destination 64.84.29.204? Yes, destination address is that. Is the traffic HTTP? Well, no, because the destination port and the protocol suggest that this traffic is not HTTP, so there is no match on this statement. So we're going to the next statement. Is the source in this network? Yes, the source is within this network. Is the destination anywhere? Well, destination is 64.84.29.204, but we really don't care because this IP address belongs into any IP address in the world, so we're good to go. There is a match. Is the traffic SMTP? Well, port 25 and protocol TCP suggest that this traffic indeed is SMTP traffic or simple mail transfer protocol traffic, so there is a match, and this statement says the traffic should be permitted, so the traffic is permitted to go on its way. Then if the traffic is sending, let's say, FTP traffic to yahoo.com, tries to obtain some files from over there, when the traffic again is checked against this access statement, we'll start in top-down approach from statement 1 again. So again, is the source within this network? Yes, the source is within this network. Is the destination this destination? Yes, destination match. Is traffic HTTP? No, traffic is not HTTP, so no match. Going to the next statement. Is the source 200, 200, 200? Yes, the source is 200, 200, 200, 200. Is the destination anywhere? Well, yes, anywhere is the destination. Is traffic SMTP? No, traffic is not SMTP, so there isn't a match. So we're going to the implicit deny everything, which will basically deny everything, but we'll do exactly what the access does, meaning it will check, is the source anywhere? Well, yes, 200.200.200 falls into anywhere. Is the destination anywhere? Well, yes, the destination also falls into anywhere. And is it all types of traffic? Well, FTP traffic, which is port 21 and protocol TCP, falls into category of all types of traffic, so there is a match, and then the access list will actually drop that type of traffic. Okay, now that we saw how we can use access lists and how exactly access lists work, let's learn how to configure access lists. We'll start with the standard access list. To configure standard access list, you have to go into global configuration mode and type access-list, then a number between 1 and 99, because remember, when we're configuring numbered access list, and that access list is standard access list, we have to use a number between 1 and 99. Then we type permit or deny, and then we type the source IP, and then the wildcard mask. Remember, the wildcard mask, also called an inverse subnet mask, was a concept that we just mentioned in a special video that we have created specifically designed for wildcard masks. So if you don't know how exactly do we find wildcard masks or what are the wildcard masks used for, I suggest you go back and review the video that is called Understanding Wildcard Masks. Now, also, you can configure all the access statements with that specific command. So just every single statement, will have to be the same access list number, and then it's going to be the permit or deny. Remember also that in the end of every single access list, there's an implicit deny everything. And you can actually comment on the access list to tell or to specify what the access list actually does if you use access-list, the number of the access list, and then remark, and then some message. This will basically create a comment on the access list saying, okay, this access list does this, or this access list does that. Great. Well, now we learn how to configure an access list, but we haven't applied the access list on the interface, and we haven't specified on what direction does the access list actually should work. To do this, or the command to do this, is typing IP access-group, the access list number that we want to apply, and then the direction inbound or outbound. The command is typed within the interface that we want the access list to work on. And again, the access number is nothing more but the access list number that we have created previously. Now, those are the only two commands that you need to know of how to configure a numbered access list. So let's see how we can create a numbered access list to solve some problem. Imagine here now we have the yahoo.com and the HTTP and FTP server from some other location. Both of those destinations, or both of those sources, can send packets to our internal network. Well, we don't want to do that. Imagine we want to block HTTP traffic that is coming from the branch server to the local area network in the headquarters, but we don't want to block anything else. So how can we achieve that? Well, we can use a standard access list to do this. All we have to do is go into global configuration mode of the HQ router and type access-list, then some number between 1 and 99, in our case 10, then deny, and then we have to specify the source. From where do we want to deny the traffic? We want to deny the traffic that is coming from the branch network, so we have to type 192.168.2.0 and then a wildcard mask to 0.0.0.255. Okay, but then we want to permit everything else. If we leave the access like that, remember in the end there is an implicit deny everything, so this access will block absolutely everything. So that is why we have to type the next command, which is access-list 10 permit and then 0.0.0 for source network, because we don't know where the source network is. We want every single network, and then a wildcard mask of 255.255.255, which would basically say I don't care about any kind of bit configuration, meaning I don't care any kind of IP addresses. After this access would work perfectly, but now we have to actually apply the access list on the given interface. The best location to apply the access list is on the 00/0/0 of the HQ router in inbound direction. So what we have to do is we have to go to that interface by the command interface.0.0/0/0/0 and then type the command IP access-group, the access list number which is 10, and then the direction in inbound direction, meaning that this access list will check traffic that is coming into that interface. Now if we have a traffic from the branch office coming into the headquarters, the traffic will be checked against the access list, and the source is 192.168.2.100, which is within the 192.168.2.0 network, so the traffic is actually blocked because there is a match. And if we go to yahoo.com, if Yahoo is sending packets, it will be no problem. Why? Because Yahoo has a source address of 64.84.29.204, and there will be no match on the first statement, but there will be match on the permit any, meaning permit any kind of IP address with any kind of configuration. But what happens if the branch office or branch server sends FTP traffic, not HTTP traffic? Well, the FTP traffic will also be blocked by the access list, because the access list is a standard access list and all it cares about is the source or where the traffic is coming from, and does not care whether the traffic is FTP or HTTP. So we kind of partially solved our goal or our requirement, but to block traffic that is coming from the from the branch server, but we wanted to block only traffic that is HTTP, not FTP or any other type of traffic. Well, to do this kind of distinction, we'll have to use extended access list. We saw that we cannot solve our problem with a standard access list. That's why we have to configure an extended access list. To configure an extended access list, it's not much of a difference than configuring a standard access list. However, you should take into consideration that an extended access list has different matching criteria than a standard access list. Now that we saw the need of an extended access list, let's see how we can configure it. To configure a numbered extended access list, it's not much different than configuring a standard access list. However, you should remember, or you should recall that an extended access list has a different matching criteria. We're matching source, destination IP addresses, source, destination protocols, ports, and everything. That is why it might be just a little bit different. But to configure an access list, you still have to go to global configuration mode and type access-list. And now, because this is an extended access list, you have to use a number between 100 and 199. Then, just like a regular access list, you have to type permit or deny. Now here though, you have to type protocol, meaning for what protocol you're trying to filter on. If you use an IP protocol, this means that you're going to match all the possible protocols out there. And there can be different protocols, can be like TCP, NCP, UDP, EIGRP, and so forth and so forth and so forth. So all the different protocols that can be used in today's networking. Then you type the source, meaning where the packet is coming from, and the source wildcard mask. Also, you can specify a source port, but we all know the source port is actually not used for communication. It's basically used to define different sessions within the same type of communication, and they tend to change. So source is highly, optional. But after the source, you have to type destination address, destination wildcard mask, and destination port. Now, if you want to match a specific type of traffic, let's say HTTP or FTP, well, that means you're going to have to use a protocol TCP and port 84, destination port 84 HTTP, or destination port 21 for FTP. Also, the no access list and the access list number removes the entire access list, and you can make a comment on the access list using the remark keyword. To apply an access list or to apply an extended access list on an interface is no different at all from a standard access list. All you have to do is type IP access-group, the access list number that you want to apply, and then you type in or out, meaning the direction that you want this access list to work on, an inbound direction or an outbound direction. After that, you're all done, you're all set, you don't have to do anything. Remember that just this command, the IP access-group, is typed within the interface that you want the access to work on, and the creation of the access list is done in global configuration mode. Now that we know how to configure an extended access list, let's see if we can solve our problem before. The goal is still the same. We have the branch office and the Yahoo server. They both can send traffic to the headquarters, but now we want to block only HTTP traffic that is coming from the branch while permitting everything else. And now we're going to use an extended access list to fix that. So in global configuration mode, we would have to type something like this: access-list 101. Remember, an extended access list comes in a number between 100 and 199. Then deny, meaning we want to block any kind of traffic that is matched by this statement. Protocol TCP, and then the source will be 192.168.2.0, meaning anything that's coming from this network with a wildcard mask of 0.0.0.0. See that I haven't typed any source port, but for the destination I have typed the keyword any. The keyword any means any kind of destination. No, I don't care where the traffic is going to. And you can substitute the keyword any with the destination network 0.0.0.0 and destination wildcard mask 255.255.255.255, which is the same network and wildcard mask that we used in the standard access list just before. Also, since I want to match only specifically HTTP traffic, that means I use the TCP protocol, but I also have to specify a destination port, and a destination port was 80. So to specify it, you have to type EQ80, and now the combination of TCP and port 80 gives me HTTP traffic. But we want to permit everything else, so what we have to type is we have to type access-list 101 permit, and now we're talking about an IP protocol. Why? Because I mentioned before that if you want to match all the possible protocols, you have to type the protocol IP. And then source address would be 0.0.255.255.255.255 for wildcard mask, which basically means any kind of IP address. So the source could be anyone, and destination is any, meaning that actually the 0.0.0.255.255.255, as I said before, can be substituted with the keyword any. And now this statement will permit any kind of traffic. So after that, we created access list, but now we have to apply it. Well, we're going to apply it in the same place we applied the standard access list. We're going to apply it on the headquarters router on interface 0.0/0/0 on inbound direction. That means that we have to go to that interface by typing the command interface 0.0/0/0/0 and then type IP access-group, the access list number, which is 101, and then type inbound direction. Now, if HTTP traffic is coming from the actual branch network, when it comes to the router will check the packet against the access list statement. So it will see, okay, the source is 192.168.2.1, which belongs within this network. Destination is anywhere, and the traffic is HTTP. So that means that the traffic should be denied. Yahoo traffic will be permitted. Why? Because the source address of Yahoo is different from the source address specifying in the first statement. That means that the access list will basically skip that statement, and we'll go to the second statement, which is the second access statement, which permits all kinds of traffic from anywhere to anywhere, which Yahoo falls into that category. Now, but the interesting point was, what if FTP traffic is coming from the branch office? Well, when the traffic comes into it, the access list will check the destination port and the destination protocol, and it will see that FTP uses destination protocol TCP and destination port 21, but we have in the first statement TCP 80. That means there is no match. That means that the traffic will be matched by the second access list statement, which permits all kinds of traffic. That means that the traffic will be allowed to go to its destination, meaning to host A. So now that we've accomplished our step, to block only HTTP traffic coming from the branch network while permitting everything else. Remember, in the end of every single access, there is an implicit deny everything. So if you want to permit everything else, you always have to type the permit IP any statement. Okay, but we also said that we can identify access lists based on the name, not on the number. And that's what we're going to learn how to configure now. Configuring a named access list is a little bit different from a numbered access list, although the principle is still the same. So let's see how we can configure. To configure or create a named access list, you have to type the keyword IP access-list, then the keyword standard, and then the name that we want to identify this access list by. Note that here we started with the keyword IP instead of just the regular access list like in the numbered access list. And also we had to use the keyword standard to identify that we want to make this access list to be standard access list, whereas for numbered access list, we simply had to use a number between 1 and 99. Now, this command actually creates the access list but doesn't create the statement. To create the statement in a named access list, you have to type permit or deny and then the source or where the traffic is coming from and then the source wildcard mask. Also note that we don't keep typing access list and then something like in numbered access list. In numbered access list, we had to type access list and then a number every single time we want to create a statement. Here you simply type permit or deny and then the access will take care of the rest of it. Also note that there is something called the sequence number here, which is optional. Basically, a named access list marks every single statement with a sequence number. Usually the increment is go by 10, which this sequence number allows you actually to modify the access list or modify a single statement in the access list. Whereas a numbered access list, you have to delete the entire access list and then recreate it again in the modified version. Here, all I have to do is just to specify what sequence number or what statement I want to modify, and I'm all good. Note also that we're not in global configuration mode. We are actually right now in config-satd for standard, and then NACL, which is named access list. In numbered access list, all we had to do is we were staying in global configuration mode, but here we actually are in a different mode. To apply an access list, or to apply a named access list, you have to use exactly the same command that you use for numbered access list. You have to type IP access-group, but this time we identify the access list by the name, so you're going to type the name and then the direction you want this access list to work on. Again, the access is applied on the interface that you want the access to work. Also, to delete an access list or to delete a named access list, you just simply have to type no and then the statement that you used to create the access list. Remember also that there is an implicit deny all in the named access list as well. So now let's see an example of how we can configure a named access list. We have the same exact example where we have the Yahoo and branch offices sending traffic to our HQ. And what we want to do, we want to block traffic coming only from Yahoo, and we want to create it using a named access list. So what we have to do is we have to go into global configuration mode and then type IP access-list standard and then the name. I'm just going to choose the name Yahoo. Then what we actually have to go is we're going to go into config-satd NACL sub mode, and this is where we're going to type our permit and deny statements. So what you can do is just type deny 64.84.29.204, which is the IP address of Yahoo, and then the wildcard mask of 0.0.0.0. Also remember that I can substitute the 0.0.0 wildcard mask with the keyword host in front of the IP address, and it will do exactly the same thing. But since we wanted to block only Yahoo traffic, that means we have to permit everything else. So that is why we're typing permit any. After that, we have to apply the access list, and the most logical place to apply the access list is in the inbound direction on interface 0.0.0. So that is why we're going back to global configuration mode using keyword exit, and then we're going to the interface, which is the 0.0/0/0, but we're using the command interface 0.0/0/0, and then type IP access-group Yahoo in, which will create an inbound access list applied right there. So now if Yahoo is to send a packet, it will be blocked by the access list. But let's see how we can configure an extended named access list. To configure an extended named access list is exactly the same principle as the standard named access list. All you have to do is type IP access-list, the keyword extended now, and then the name that you want to identify this access list with. And this will create an extended access list. After typing this command, you will go into config-ext NACL, and then in this mode you can type all your access list statements, which is permit or deny, the protocol, the source, meaning where the traffic is coming from, source wildcard mask, source port, which is optional, then destination wildcard mask, and then destination port. Remember also that the protocol and destination port identify the traffic that is being. Let's say, for example, if protocol is TCP and destination port is 53, then we're talking about DNS. Or if destination port is 22, we're talking about SSH. Also, in standard named access list, we have the sequence number, which is optional and which allows us to modify the access list or modify a specific statement of the access list. To apply the access list, you have to just go into the interface that you want the access to work on and type IP access-group, the name of the access list, and then the direction that you want the access list to work. Now, if we have this diagram also to see how we can use an extended access list, let's say we want to block only SMTP traffic that is coming from host A and is going to the Yahoo server. So what we can do? Well, we can go into global configuration mode and type IP access-list extended and then the name. Well, I'm going to choose the name Yahoo again. This will take us into the config-ext-nacl mode, and then here we're typing deny TCP 200.200.200.200, which is the source because the source is host A. Then wildcard mask 0.0.0.0. And then the destination is Yahoo server, which has an IP address 64.84.29.204. And since it's a single IP address, a single host, I had to use a wildcard mask 0.0.0.0, but I decided to substitute that with a keyword host. You can also do a keyword host as the source, but I just wanted to show the 0.0.0.0 to see that you can actually have that option. And then after the destination, we have to specify destination port, which is 25. So TCP 25 is exactly SMTP traffic. But since we want to block only SMTP traffic, we have to permit the rest of the traffic. So that is why we're typing permit IP any and then 0.0.0.0 for destination, because I don't know what my destination is since it's everyone. And then wildcard mask of 255.255.255, since I don't care about any kind of bits configuration on the IP address. Again, you can substitute this with the keyword any, but I just chose it to you for clarification. After that, we have to apply the access list, and one logical solution would be to apply an inbound direction on the local interface of the HQ router, but you can also apply it on the outbound direction on the 0/0/0/0. And it has to be an outbound because the flow of the traffic is that the traffic is going out of that interface to reach the Yahoo server. So that is why we're going into global configuration mode by typing exit, and then we're going to the interface 0/0/0. So we're typing interface 0/0/0/0 and then IP access dash group Yahoo out, which will apply the access list Yahoo in outbound direction. So all SMTP traffic from host A that is going to Yahoo will be blocked. Remember that we said that we use access lists to filter traffic that is going through the router. We cannot filter traffic that is going to the router itself. The only traffic that we can filter that is going to the router is the VTY traffic, which was Telnet, SSH, RLogin, basically any kind of remote access to the router itself. Well, to do this, we need to create an access list, and we're creating the access just like we've been practicing so far. But applying the access list, that we do not apply it on the interface. We actually apply it on the access list on some other location. And that location is in the VTY lines. And then inside of those VTY lines, we type the command access-class, then the name or the number of the access list that we can use to filter the VTY traffic, and then the direction that we want this access list to work on. So if we apply an inbound direction, that means that the access that is identified by the name or the access list number will filter all VTY traffic or incoming VTY traffic. If you apply it in outbound direction, that means that the router cannot telnet to or cannot SSH to a remote location. And that is it. So let's see how we can filter a VTY traffic from host A to the HQ router, meaning how we can prevent host A of telnetting to the HQ router. So what we have to do is first we have to create an access list. Well, the most basic access that we can create and to do the job is creating a standard access list. So what we're going to do is we're going to type access-list 10 deny and then the host that we want to deny, which in our case is 200.200.200.200. And then we want to permit everything else. So we're typing access list 10 permit any. Remember that numbered access list is typed in within global configuration mode, and we have to keep repeating access list 10 every single time. After that, we have to go into the VTY lines of the router, not on the interface. So we're typing line VTY04. Remember, those numbers is the number of simultaneous connections that you're allowing on the router. In our case, we're allowing 5 simultaneous connections. So that is from 0 to 4. And then inside of the VTY lines, we type access-class, the access that we want to play with, and then type the inbound direction. Now that means that the host A won't be able to telnet to the HQ router. We can use the command show IP access lists or show access lists in privilege mode to verify what commands we have configured. And this command will display all the access lists that we have on the router. So if I type this command in the HQ router, I will get 2 commands. I will get 2 access lists. I will have one standard access list with a number 10 that is denying host 200.200.200.200 but permitting everything else. Also, we have another access list which is an extended and it's named access list with the name Yahoo, that is blocking SMTP traffic from 200.200.200.200 to go into 64.84.29.204, which is the Yahoo server, and then permits all kinds of traffic. The numbers that you see, 10, 20, 10, 20, those are the sequence numbers of the access list. As I said before, we can use those numbers to modify a specific statement on the access list. However, those numbers actually work only on the named access list. So even though they're saying in the numbered standard access list 1020, they will not be able to modify a single statement on the access list. That means you have to delete the entire access list and then recreate it again. And that's it. That is all you need to know about access lists and how do they work. And now you can use that knowledge to filter traffic that is coming to your network or is going out of your network. So what we just did today is basically we talked about that access can be used for two major things, for classification and for filtering. Also, we said that access work on the actual interfaces and they have a direction, inbound or outbound direction. And inbound and outbound access lists filter or check different traffic, meaning incoming traffic or outgoing traffic. Then we said that there are two main types of access lists, standard access list and extended access list. Standard access list have check only against the source address, where extended access list check source, destination, protocols, ports to make their filtering decisions. And then we'll learn how we can configure standard access list, and then we had the extended access list as well as numbered and named access lists. Thank you for studying CCNA with Vombar, and have a great day. Bye.